Okay, thank you for having me, Ingo. Ango, as they say in Scotland, right? Yeah, I'm going to talk a little bit about the kind of problem I'm working on, because I think it's relatively unique, different from the rest of what you see out there, and not so much technical solutions, but more philosophical solutions, the way people approach this problem in this domain. So to begin with, we've got, I do legal information retrieval in the form of electronically stored information. And when most people think legal, they think patent search, right? This has nothing to do with patent search. Electronically stored information is the data from a company itself that is involved in some sort of litigation known as eDisclosure in the UK, trial preparation, or information governance. And I'll get into what those are, and then I'll follow this by the principles that people use to address these issues. So you're at a corporation, and everything that you have created in your work, all your emails, all your PDFs, Word docs, Google Docs, Slack chats, database entries, is all electronically stored information that could be relevant to a civil, criminal, or regulatory matter. And the idea is that among this collection, you have to be able to find everything that is relevant to that matter, and often in multiple languages as well. If you're working in a multinational cross-border environment. So a typical ESI collection can range anywhere from, say, 50,000 documents to 10 million documents, with an average size, I would say, of probably about 200,000 or 300,000 documents. From a web perspective, that's nothing, tiny. But the point is that you have to find everything or almost everything, and that's typically, a collection is typically about 10–15% rich. So if you've got 300,000 documents in your collection and it's 15% rich, that's 45,000 documents you have to find. In order to correctly solve the problem. So, technology-assisted review. That's the trial prep and governance are the three areas I talked about. Technology-assisted review is the notion of finding almost all relevant documents. Trial prep is the notion of finding the documents that make your case. And governance is finding problematic documents at your company before they become problematic. So for finding all relevant documents, I'm going to give you some hypothetical examples. These may or may not conform to some real world situation that you have heard of, but imagine that there's a large database company suing a large web search engine over its use of a coffee-like programming language. The hypothetical web search engine then has to find every single document in its company related to how they use this API, not just emails, but source code, messages, meeting notes, all this, and so on. Or imagine that there's a large central European car manufacturer, again, hypothetically, that was found to be cheating on its emissions, that, there were diagnostic tests, and when it plugged in those diagnostic tests, the engine changed how it performed versus when the diagnostic tests. All right, so we have got a number of different, and in order to do this, again, you have to find 80% or more of the responsive documents. Every case is unique. It's a collection just for that one user or small team of users. And the machine learning models themselves are ephemeral. There's not much you can learn across cases that transfers over. In trial prep, on the other hand, you are involved in finding the documents that make your case. So earlier, I think it was Paul who was talking about the difference between relevant documents versus the important documents. You have a similar situation here where there are a certain number of documents that are relevant within the collection, but only some of those relevant documents are what's known as probative. Probative are documents that you'll actually enter into trial to try to convince the judge to, the evidence that you present to make your case, and not all 45,000 documents in the collection are going to do that. So what you ideally want is, like, suppose you are in court against Frank because you think Frank stole a fancy television from somebody's house, and you're you're the plaintiff and Frank's the defendant. If you can find an email that says from Frank saying, I broke into the house and stole the fancy television, that would be great. Typically, people don't explicitly say what they're going to do, though. What you'll instead find is maybe the victim posted the fancy television on picture of the television online. Frank's in that forum, so you know Frank saw it. Frank has a sales receipt for lock picking tools. His cell phone was pinging towers in the neighborhood when the burglary occurred. And he also sold a fancy television on eBay shortly thereafter. But so if you found all these documents, this could help your case. But at the same time, your opponent might find documents that say that Frank's house was actually recently broken into. And as a result, he enlisted in a local college course on physical security to protect himself, to understand how these things work. And that's why he bought the lock picking tools, because it was part of the college course. And because he felt unsafe in his neighborhood, he decided to move to a different neighborhood. And that was the neighborhood that in question here. And so he has if there's a receipt for an apartment rental deposit in that new neighborhood. And he also was downsizing from his old neighborhood to his new neighborhood. And so he ended up selling his own television. Those pieces of evidence tell a completely different story than the first few pieces of evidence. So what you have to be able to do is find the documents not only that make your case, but that prevent your opponent from making their case, because they're going to be looking for documents that show evidence in a different direction that you might want to find. Finally, we have internal investigations, and that's finding problematic documents before they become problematic. Things like the GDPR, you want to see if your company is in compliance, is behaving properly with respect to the GDPR. The UK Bribery Act, you are not allowed to bribe officials of foreign governments to get favorable business status, and you want to see if anyone at your own company is engaged in those sorts of activities. Sexual harassment, finding out whether there are employees who are engaged in sexual harassment or insider trading or violating environmental laws and so on. Here are a couple of examples that really illustrate how difficult this is. In the first example, this is an actual chat from a regulated finance trading system in which traders are required to communicate over this system. And we have here an example of a senior yen trader saying that the whole high finance world will be kissing you instead of calling me if the London interbank offer rate, the LIBOR, you remember the LIBOR scandal a few years ago? If the LIBOR moves lower. The other guy says, okay, I will move the curve down. And the first guy says, okay, maybe after tomorrow's fixing. This is a very easy document to find. They really talk about moving the curve down and price fixing. You can find it with a simple search. On the other hand, you have an aide to the governor of New York who was asking for bribes, but he wouldn't call it money. He would call it ziti, you know, this pasta. You know, if you give me some ziti, I'll make sure, you know, what you want to have happen happens. Right? That's pretty transparent. Most people reading that understands that when he's talking about ziti, he's not actually asking for pasta. But at the same time, if you're thinking about how do you search for this, and if you're thinking about whether all your fancy BERT and attention models and everything will capture this, ziti is not the context here. You would never find ziti because he's using it in a non-standard way, purposely. More sophisticated was a group of traders at a company who had developed a sophisticated language based on golf for triggering trades. So one would try to communicate to the other and say, okay, if there's a birdie on hole 2, that means buy stock number 2, right? And then already worked out which stock number 2 was, what hole 2 stood for. You know, par on hole 5, that means don't sell, don't buy, hold your position. You know, I hit his hand trap on hole 7 and so on. How do you find this information, right? For all intents and purposes, the investigators, when they were looking at this, they read these messages and said, oh, these guys are just talking about golf, right? Because you can talk about personal stuff on work emails and work messages. There's nothing wrong with that. But then later, they got the feeling and went back and noticed that the date on these communications was, so the location on these communications was Boston, Massachusetts, and the date was February. So I don't know if you know Boston, but golfing in February is not something that happens very often. And again, your BERT attention models probably don't have the weather conditions in Boston built into them to sort of really know that this word means, you know, Par and Birdie really means this in Boston in February. So how do you find these things? These are the principles. Again, I'm not going to give you a specific technical solution. I'm going to list the principles that people go by when they're trying to understand what does and doesn't work. And the first one is collection completeness. I guess I should say before this, you know, we're all familiar with this famous graph from a 2001 Microsoft research paper where you have different algorithms in the different colors here. And the x-axis is the amount of training data. And as you increase the amount of training data, an algorithm that initially looked like it was the best performing algorithm came out to be the worst performing algorithm, right? So this is one of the, you know, one of the pieces of lore that is used to say how important big data is and training on massive collections is. Well, what nobody ever seems to talk about is the fact that if you turn this graph around, the algorithm that was the worst performing algorithm suddenly becomes the best if you don't have big data. And so this is the situation we find ourselves in with eDisclosure and information governance. You don't have a lot of data, and the things that you're looking for are often very specific, and there are not broad distillable patterns in what you're looking for. So collection completeness. The first thing that people do is they make sure that if they're looking for information, they've got everything that could possibly potentially be relevant. So people spend a lot of time just assembling the collection to begin with. Often in search, we think of it as, okay, whatever data we have that we're searching, that's what we have, and that's just what we have to search over. But here they actually go out and might look across old tape archives to try to find things that could have gone missing. And what this screen right here is, it doesn't matter what the details of it are. The point is that people are doing an analysis of what could possibly have gone missing by looking at communications patterns between various individuals and looking for gaps in those patterns. And that is a clue to say, okay, maybe there's some stuff here we're not aware of, and let's go out and find it and try to figure out where that collection might be located, on what old archive. Number two is the importance of process. Or in other words, I love this quote by Sartre, statistics can never be dialectics. We're in love in the machine learning information retrieval world with statistics. But if you think about an evolving information need, the sort of the dialectical nature of the information you're seeking, your statistics are never going to find it. So where this comes in is, you know, in a typical machine learning approach, you know, you get your data, you clean it up, you do some feature engineering, you try a couple of different algorithms, you model it, you maybe tune it, try a different model, a couple of iterations of this, mostly done from the perspective of the data scientists, and then you deploy it and monitor it to see if it's working. But the moment you've deployed it, it's done, right? Your model is fixed. You don't continue working with it at that point. In a technology-assisted review eDisclosure environment, however, an individual model is given to every individual working on the problem, and that model continuously updates itself in real time, and they're able to get different predictions based on what they're doing. What they were doing 5 minutes ago affects what happens 5 minutes later. So it's intense, user-specific personalization. Maura Grossman and Gordon Cormack had a very interesting paper a number of years ago that has really influenced this field, in which they experimented with this. What we have here is the various SAL approaches are the idea of training a machine learning model using active learning, and so uncertainty sampling, finding the documents that the machine is most uncertain about. For 2,000 documents of training in the red, and then releasing that and letting that model predict from that point forward. And you can see after the training that the model does a very good job in predicting. For 5,000 documents of training, or for 8,000 documents of training. And you can see at each point that the more training you do, the better your model gets, whereas the continuous approach at the top in the circles is starting not with training using uncertainty, but training using relevance feedback and iterating the heck out of it, constantly taking the top of the ranked list and for hundreds, thousands, tens of thousands of documents, continually feeding it back. And that beats all of the approaches in which a static model is learned based on uncertainty. So, and that I noticed that's something that Paul Levay was talking about earlier today as well. He had a slide in which he was showing a couple hundred documents of random training and then releasing the model. They found that the continuous approach was a much better approach. So a lot of the research in this area goes from optimizing the model to evolving the process, the interaction with the models. And this slide doesn't matter. It's just a quick flash of the almost dozen different ways in which that process, changing of the process as you're searching for information, has made significant improvements to the overall outcome of a technology-assisted review process, none of which have to do with the actual weights of the machine or the machine learning model itself. Principle number 3. Ingo, how am I for time? Am I going till 25 after? I know I was interrupted there in the middle.
If you could finish soon, because we have to start, Ricardo has to start at past.
Okay. So encouraging curiosity. This was a point that Marianne made during her talk as well. So optimization hinders evolution. We're used to optimizing our models, but the moment we've optimized them, we can no longer evolve. Think about back to the probative document case. The way a lot of people work in eDiscovery and eDisclosure is to have interfaces that allow you to dynamically change what you're looking for and have the system react in real time to that. Tony, you just spent a lot of time this past half hour talking about this as well, and I love how aligned we are with this thought process of real sort of dynamic interaction and what there's a colleague of yours, Tony. Do you know Rebecca Feebrink? She's a reader at Goldsmiths. Yeah, so she gave a presentation a couple of years ago, and what she does, Rebecca creates new musical instruments, right? So she's not an information retrieval person, but the way she creates them is by using machine learning to train the instruments. But contrary to typical machine learning, in which you start with ground truth and a big data set and then pull or extract some sort of model out of that data set, what she did, there's no ground truth in this machine learning, but people are using data dynamically in real time to communicate how they want the computer to behave, and the computer is modifying itself in real time based on the things that it is teaching them, that the user is teaching them in the moment. So it's a lot more reactive, a lot more intentional. Which is, again, this designing for evolutionary processes is something that Marianne mentioned as well. I think I'm going to skip the last two. Skip the last one. Proprioception. So proprioception, I've noticed when working with lawyers, what they want to do is they want to understand what the system is going to do for them. And proprioception is the notion of being able to sense where your body is without being able to see it. So I can take this this red ball right here, and I can magically move it behind my head to my other hand without having, oh, there we go. Yeah, Zoom is deleting a bit of the video here. I can move it around without having to look at it because I know where my body is, I know where my hand is, I have a feeling of what's moving and where without actually having to transparently understand exactly what my body is doing or see what it's doing. So the idea behind proprioception is that even if something is not transparent, even if something's not explainable, Luke here with the blast shield down, not being able to see this little ball floating around in Star Wars, he still has a proprioceptive sense of where everything is and is able to act appropriately. So you'll see this with lawyers. It's been talked about, Tony talked about how they have these long Boolean queries. And what I think is happening here is not just the fact that they're unwilling to use more advanced search tools, but the fact that they proprioceptively want to see that as they add and remove different facets of this big old Boolean search, what happens to the system? How does the system react? we've observed this with the machine learning that people do. Users will go in, they will tag a bunch of documents as responsive and non-responsive, relevant and non-relevant, and then they will remove some of the documents from the training and look at how the list changes in real time. So the system gives them a new prediction, and then they'll put those documents back in and sort of see what happens as they move documents in and out. And what I think they're trying to do is get a proprioceptive sense of the what ifs, as Tony was saying. To see how the system will perform, even if it's not transparent and even if it's not explainable. So I would say in this discussion that the community as a whole seems to be having between transparency and explainability, I would argue that proprioception, if the system will react to you quickly and you can see what the effects of your actions are, that proprioception is probably a better thing to optimize for than either transparency or explainability. So I'm going to wrap things up there, just in the interest of running out of time. A lot of with just one more comment, a lot of the web world talks about optimizing for engagement and wanting to make sure their users are engaged. And what Rebecca found is that when people have the ability to interactively play with the system and the system responds in the moment to what they're doing, basically respects the decisions that they're making and the actions they're trying to take, they spend a lot more time, not just, even though they can create an instrument in hours, they'll often spend days or even weeks fooling with it because they're having such fun seeing what happens and seeing what they can create. So perhaps there's something in there in the search systems we design, if we can give people a better proprioceptive sense, they'll become more engaged with the tools that they're working with. And so, thank you.